Hi, my name is Simon Willcock and I'm going to introduce you to the EnsemblES project. This is a collaboration between Bangor University and the Centre of Ecology and Hydrology looking at how ensembles of models might improve ecosystem service decision making. Despite some claims of superiority of certain modelling techniques and platforms, independent evaluations that compare ecosystem service model estimates with available validation data have often been unable to demonstrate the preeminence of any single one. This is problematic as the models rarely completely agree, and so if no ecosystem service model is known as the most accurate, which one should you use? How should the model be selected? Furthermore, once you have selected a model, how can you be sure that the results are not dependent on the model you chose? One solution to this is to use ensembles of models, which basically involves running multiple models and drawing the conclusions from some combination of their outputs. Model ensembles are widely used in other disciplines, however, they have not been widely applied in ecosystem services. So in this project, we will develop UK-wide ensemble models for a provisioning service, water supply, and a regulating service, carbon storage. These are two of the most widely assessed ecosystem services, and they have a wide variety of independent models available. So we will choose approximately 10 models for each of these services, and then compare these models to independent validation data. For example, we'll compare the water models to the average water flow through a series of British catchments available from the National River Flow Archive. We can then carry out this validation for both the individual models themselves to identify which actually is the best model compared to these data, but also for various different ways of combining the models. So what is the best way to form an ensemble? Is it a simple calculation of the mean or the median, or is it something more complex? Some of our possible combinations are shown on the next slide. Here you can see some of our preliminary results for the water models. Typically, the best individual model outperforms an ensemble on both the metrics we use here, which are Spearman's row and inverted deviance. And these are both methods to describe the fit of the model outputs to the independent validation data. However, the green data shows that some methods of creating an ensemble, for example cross-validation with AIC, are also very good fits to the data. Thus, these methods should be used when the best model is not known, and this is quite often the case, for example when you lack data or because you're trying to predict a future scenario. Even when you know the best fit model, it may also be better to use an ensemble, as this may be more robust to new data and new models coming in, and it may also prevent that rigidity if future events mean that your model predictions are no longer accurate. We'll investigate model transferability by asking if an ensemble trained on one portion or one of the data or one data set can then estimate an independent portion, and so far our results are positive, and this is shown on these graphs in blue. Finally, and not shown here, we will study the sensitivity of the models and the ensembles to input data. Typically, this involves using land cover maps of different resolution, and so far our results seem to indicate that the more resolute land cover maps produce more accurate model outputs. So whilst this work is still very much ongoing, we hope that our outputs can support ecosystem service decision making in the UK. We've invested considerable resources in running multiple ecosystem service models and identifying the best methods for combining these models. Whilst the latter is quite useful to other modelers, many people would rather have direct access to a robust layer that they can use. And so we will be making all our ensemble layers outputs available. We will also include the uncertainty of these outputs. So, for example, shown here is the uncertainty, shown as the standard error of the ensembles of some of the carbon models that we have run in this project already. Thank you very much for listening, and please do get in touch if you have any questions.